Hello students, today we will go for a new and interesting topic. And if I go back to the last video, there we discussed about the addition and subtraction of vectors. And in the addition, we used three laws to calculate the resultant of two or more vectors. What are you doing there? Addition of vectors means we are finding the resultant of two or more vectors, means simultaneously at a point or at a body, simultaneously at a point or on a body, two or more vectors are acting. Then by using these laws of vector addition, we can calculate the combined effect of all the vectors. That is called resultant. That we have discussed. That we discussed in the last section, in the last video. Now, today in this video, we will discuss about the reverse of or the opposite process of addition of vectors. So that is your resolution of a vector. Resolution of a vector. We will discuss about resolution of a vector. Clear? So here we will discuss about that we have the resultant. This resultant R is because of vector P plus vector Q in addition of vectors. In addition of vectors, R is equal to, suppose we have P and Q are the vectors, the resultant R is equal to P vector plus Q vector. That we know about in your addition. But here R is given to us. We know that R is there, and by that using R, we have to show that this R comes because of P vector and Q vector. Because of P vector and Q vector. This process is called resolution of vector. Clear? So the resolution of vector, we can say that just opposite to the process of addition of vectors. Clear that? Is that clear? Okay. So let me write what is this resolution. It is the process of splitting, breaking that vector, makes into parts, split that, right? It is the process of splitting. It is the process of splitting of a vector. It is the process of splitting of a vector into two or more components. Two or more components. In polygon law, if more than two vectors are acting on a body, you are getting the resultant R. So that is more than two vectors are there. In triangle law, parallelogram law, we are getting the resultant of two vectors acting on a body. So accordingly, it is the process of splitting of a vector into two or more components. P and Q are the components which gives me the resultant R. So they are components. R is given to us. We have to find out P and Q. So into two or more components, right? Okay. So two more components is known as resolution of a vector. Resolution of a vector. Is that clear? is known as the resolution of a vector. And the components or the parts we obtain by breaking that vector, we are getting the components. These components are called as the components of the vector. The parts obtained, the parts by splitting, what are you getting? These are the parts. The parts are called as components of the given vector. Components of the given vector. And what it means? Go to the addition. It is just opposite process of addition. Go to your addition. If the vectors P and Q, let us take for two vectors example. If the vectors P and Q act simultaneously on the body, then we are getting the resultant R, which is equal to P vector plus Q vector, and its magnitude and direction, that is different part. We derive that thing. What it means? If P and Q are acting simultaneously on the body and we are getting R, means remove that P and Q, now you apply R, you will get the same effect. Here also, R is applied to the body, but remove that R, use the components of this R, you will get the same result. Right? So, the way of approach is different. The way of approaching that point is very different. We know if in addition, R is my final, P and Q are initial. In resolution, P and Q are my finals, R is the initial. R is given, it is initial. That is the difference. Clear? I think it is almost given some idea to us. Yes, right. So the parts are called as the components of the given vector. So it means we can say that a components of a vector in any direction, the components of the vector in any direction gives a measure of the effect of the given vector in that direction. Effect of the given vector in that direction. So a component, another point you can write, a component, what the components are getting? A component of a given vector, you are getting two or more components. If there are two vectors are giving the resultant, then you are getting two components. Then a vector is given, you can make it number of components, more than two also. So a component of a given vector, pick up one of the component, and what this component says you. So if this is the vector and this is a component, then we can say that this vector has an effect on this direction, if this is the component of this vector. If this is the vector and it is a component of this vector, so we can say that this vector has an effect in this direction, So I will write in this thing. A component of a given vector, in any direction, gives the measure or gives the effect. We can write the measure or gives the measure of the effect. Measure of the effect of the given vector, of that vector in the direction. In which direction we are finding? In that direction, it is giving the measure. So a component of a given vector in any direction gives the measure of the effect of the given vector of the vector in that direction. Make it clear. In that direction. Okay. This is the resolution of a vector. Okay. Now we'll go for a simple example. How this happens and what this. Now we'll go for a simple example. Clear? Let me read this one. Clear? Now let me read this one. Now let us consider we have the vector r. Let us consider we have the vector r. This is my vector r. It is given to me, the vector r. Okay. So let us consider vector r, which is to be resolution means we are getting resolved, splitting. Let the vector is resolved into two components along the direction of the vectors, p and q. P and q. Are you clear? R is the given vector. I want to find the components of R along the direction of p vector and along the direction of q vector. Means what is the effect of R vector along the direction of p vector and along the direction of q vector. That I have to calculate. That is the process of resolution. This is the process of resolution. Yes, this is the process of resolution. Clear? Let the vector R is represented by a line like this, vector R, clear, by the line A, B. It is given. Is that clear? Yeah. Now, draw a line parallel to the P vector. Draw a line parallel to the P vector. So this is my line from A. Draw a line parallel to P vector. This is the line parallel to P vector. So the magnitude may change, but the parallel to this is the P vector, right? Parallel to the P vector. Now draw a vector parallel to this vector and draw another vector which is parallel to Q, like this. Parallel to Q. So this is the Q vector direction, this is the P vector. Clear? This is the, and this is the, suppose C. AC is the vector parallel to P. CB is the vector parallel to Q. Is that clear? Clear? So, if this is so, then AC, the magnitude of AC is not necessarily the magnitude of P. It is parallel to P, not necessarily. So I can write what? This AC I can write a scalar multiplication of P. Can we write NP? They have the same direction, but the magnitude changes. I have multiplied a scalar. This is 5 Newton along north or along east. I am using 3 Newton or 2.5 Newton along east. Means to this it is parallel to its, but the magnitude is 2.5. So I can say this n is equal to half. So it represents the same effect, right? It may be also same. So in that case n is equal to 1. If P, this P is equal to AC, then this n is equal to 1. So I put this n inside. Similarly, CB parallel to Q along the same direction, I can write this as NQ. According to triangle law of vector addition, according to triangle law of vector addition according to triangle law of vector addition, your R, or you can write like this, AB is the resultant is equal to AC, this they are in the same direction, in the same order, plus CB. So this R is equal to AC is your NP, scalar multiplied with the vector, scalar multiplied with the vector. So this NP and NQ are called as the components of the vector R. NP and NQ are called as the component of the vector R. Clear? Are you getting this thing? So M and N are scalars. M and N are scalars. Are you writing what I am telling? I have not written what the process here. From here to here, how I shifted, I am not writing all these things. It is not possible to write all these things because honestly the time wasted. So I am not doing this thing. So I am doing the mathematical part. Otherwise, you will get the notes also. In scalar vectors, you will get the notes. Okay. But if it is possible to you, then you write this. ACC. All are you familiar with my notations? ACC according this triangle according, right? So according to triangle of vector addition, this is the case. M and N are scalars. M and N are scalars. Okay. And the vectors NP and NQ are component vectors of what? R. NP and NQ are the component vectors of R. Okay. And remember one thing. This is the process of resolution. Means R is known to us. I have calculated this NP and NQ. These are the components. And remember, this is one and only. This is one and only way in which a given vector R. This is one and only way that a given vector R is resolved into the components along P vector and along Q vector. In any other way, if you apply any way, you will not find other than this any component along this AC and CB. Means you are calculating the component of R along this AC, you have to take this NP, and along CB it is NQ. So this is the unique value, unique. So that's why I am telling that there is one and only one way in which the given vector R is resolved into the components NP and NQ. Let us prove that also. Let us prove that, right? So someone will say that. Let us prove that. Let me prove this one. Because we are discussing about the physics without proof and all these things, we will not accept some things, right? We will not accept. Let us prove this thing. Let someone will write R is equal to. Let someone will write R is equal to N dash P plus M dash Q. So it is new vector. Magnitude changes, direction is same. But along P, the vector is N dash P. So remember, along P, NP is a vector. Along P, N dash P is a vector. So both are of different magnitudes. Direction may be same. Direction is same. So someone has used that. Let for him R is equal to N dash P plus M dash Q. Then according to this I can write what is this R for the first case MP plus MQ, that should be equal to N dash P plus M dash Q. Or I can write N minus N dash, take this P up this side, right? Can you write properties of vector addition? NP minus N dash P, NP minus N dash P. Okay, so you can also write like this, NP minus N dash P plus NQ minus M dash Q is equal to 0. So n of p minus n minus n dash of p plus n minus n dash into q vector is equal to 0. Under what condition this will be 0? P and q are there. P vector is there, q vector is there, because we are finding r along the direction of p, along the direction of q. So it means p and q are non-zero. So let me write here p and q are non-zero. They are not zero. They are not null vectors. They are not null vectors because they exist. If these p and q are non-zero, then if this is to be 0, this equation is 0, then n minus n dash is equal to 0. This implies n is equal to n dash. Both are same. n minus n dash is equal to 0. This implies m is equal to m dash. This is my point. There is one and only. There is one and only one way in which r can be represented, right, or resolved into the components along AC and along CB. Okay. Now we'll go for the another thing, that is the rectangular components. Rectangular components of a vector. Okay. Rectangular components of a vector. Okay. Now we'll go for the rectangular components of a vector. Clear? So here what we will discuss here, already we did discuss about the components of a vector in any direction. In any direction, and here we will consider for two directions. Now we will consider for along the direction P and Q. But what is this rectangular, perpendicular, orthogonal? Say orthogonal, perpendicular, rectangular, both are same thing, means perpendicular. So rectangular components of a vector means you are finding the components, but these components are perpendicular. Then it is called as the rectangular components. Means the angle between these two, the components, two or more components. You have a vector and you are calculating the components. Here R is the vector. You have calculated its component along P and Q. If P and Q are perpendicular, then we can say they are the rectangular components. So that means when a vector is resolved into its components, when a vector is resolved into its components, we are taking two or more components, suppose, into its components, and the components are perpendicular to each other, and the components are perpendicular. I can use this symbol also, I told in the videos. And the components are perpendicular to each other. Means right angle to each other, 90 degree. Angle between them is 90 degree. So we can write in the bracket to understand this theta is equal to 90 degree. Means angle between the vectors. Okay. Don't forget. Don't take this theta. Theta is the. Don't take theta in otherwise. Theta is the angle between the components. So theta is 90 degree. Okay. So at perpendicular to each other, then such components are called. Such components are called as rectangular components of the given vector. vector. Clear? So how to find the rectangular components? First I will go for two rectangular components, then I will go for the three rectangular components. Means I have a vector, I will take two components of the vector and the two components are perpendicular to each other. Then in the next section I will go for, I have a vector, I have three components and the three components are mutually perpendicular to each other. So like this, these are mutually perpendicular, and this is the vector and it has three components and they are mutually perpendicular. First I will, this is the vector and it has two components and they are mutually perpendicular. So first I will go for the into two perpendicular components, into two perpendicular rectangular components of a vector, into two, let me make it like this, into two perpendicular components, into two. So this is the definition, already you have written this thing, so I will erase this. I am erasing rectangular components of vector into two perpendicular or two rectangular components or two perpendicular components, perpendicular components. First I will go for two, then I will go for the three case. Okay. Now two perpendicular components. Now first I will go for, consider I have a vector A. A is the vector, this is the vector A. And this vector A is represented by the line OP. The vector A is represented by the line OP. And this vector is in my xy plane. Means in the coordinate system, if I show that in the coordinate system, this is my x coordinate and this is my y coordinate. And as you know, in the coordinate system, as I am taking for two components, so I consider only two components. Means two directions, x direction and y direction. What is the angle between x and y? Already you know that. What is the angle between x and y? X axis and y axis. It is known to you. You are very good students. You know this thing. Angle between x and y is 90. Right? So let this OP, the vector A, makes an angle theta with OX along x axis. OP is a vector in the plane in this board. This is the x axis of the board. This is the y axis of the board. They are perpendicular, and this vector makes an angle theta with the horizontal or along the x axis. You can write also. You can write what I am telling you, right? I will not write all these things, okay? We will provide the notes also, but you can write also here. Okay? So now, to know that, to find the rectangular components means if I will calculate the component of A along x axis and along y axis, then these two components of A along x axis and y axis, we can say they are rectangular components. And how many components? Two. So they are vector into two perpendicular components. That is my point. That is my point. Clear? If I calculate the component of A along this x axis, component of A along y axis, along the direction of y axis, then these are called as two rectangular components of vector A. Clear? So let this is the vector OP, which is the vector A. To calculate that, let us draw the perpendiculars like this. Let us draw the perpendiculars. And to x axis, this is the perpendicular. Let me draw like this. Perpendicular 90. This is M, and this is obviously vector A. Let us draw the perpendiculars. Clear? So after drawing the perpendiculars, PM and PM, sorry, this is M. This is M, so this is, you can say, M. Okay? Now, after drawing the perpendiculars on x-axis and y-axis, according to triangle of vector addition. So now we take this as OM is a vector, right? OM is also a vector, you can say, along this direction. and NP is parallel to OM, so this is the vector like that. And ON is parallel to MP, MP is parallel to ON, so this is the vector. Clear? We can show like this. Now, if according to triangle law of vector addition, according to triangle law of vector addition, according to triangle law of vector addition, in the triangle, there are so many triangles, you can take any triangle. In the triangle OPN, OP vector is equal to, see, ON and NP are in the same order, OP is opposite order. So OP must be resultant, ON and NP are the two vectors. By adding these two vectors, I will get OP. So OP is equal to ON vector plus NP vector. ON vector plus NP vector. But what is this NP? NP is ON. NP is ON. So I can write this is also OP is equal to ON plus OM. How? By parallel shifting. OM is the vector. I am finding the component of A along OM, not along NP. But the same thing is there. OM is the vector. I am shifting OM parallel to itself. So there is no change in the vector. So OM vector is equal to NP vector. Parallel shifting. So I can write ON plus. Now, let us denote this ON as AX vector along x-axis. You can keep the notation like this. And OM is your AY vector. OM is equal to AY vector. So I can write this as OP, that is your A vector, is equal to AX vector plus AY vector. Now AX vector along x-axis, AY is along y-axis. They are perpendicular 90 degree. AX and AY is 90. So they are called as the two rectangular components of A. So I can write here AX vector and AY vector are two rectangular vectors of what? Rectangular vectors of which one? Vector A. If A is not there, then is that AX and AY. So of vectors of vector A. Clear? Is that clear? Let us go for another interesting topic, that is the unit vectors. Already we have discussed that thing, unit vectors. And in our coordinate system, remember this thing. Or you can make a note like this. You can make a note. In that unit vectors, I should repeat this thing. I should make a note in that case also. So, let us consider the three coordinate system: x-axis, y-axis, z-axis. And this is the origin O. Always remember, in the coordinate system, if you take the unit vectors, then along x-axis, generally we will take the unit vector as I cap. Unit vector is represented cap. So the unit vector along x-axis is taken as I cap. Along y-axis, that is the j cap. And along z-axis, we will take this as k cap. So I cap, j cap, k cap are the unit vectors. What is unit vectors? The vectors whose magnitude is 1 unit and it is along the direction of that vector. So if a vector is along x-axis, suppose a vector AX is along x-axis, then I can write this as this vector in terms of I cap, unit vector. How we write? The magnitude of this AX vector, this is the magnitude of this vector, modulus, into I cap. So I cap is the unit vector along x-axis. Similarly, if AY is a vector along y-axis, then AY can be written as AY modulus of AY into j cap. If you multiply the unit vector, its magnitude is 1 unit, does not change the magnitude, but it gives direction to the vector. It will give direction to the magnitude part. So accordingly, I cap, j cap, k cap are the orthogonal or rectangular unit vectors along I cap, j cap, k cap. That always we will consider. Clear? Remember, this is required. Remember this thing. In some books, it is also given P, Q, R like that, or whatever may be notation. But my notation is that I will consider always I cap, j cap, k cap are the unit vectors along x-axis, y-axis, z-axis. So the angle between I cap, j cap is 90, j cap, k cap is 90, k cap and I cap is 90. If the angle between the vectors are 90, they are called as the orthogonal unit vectors or rectangular unit vectors. Clear? Or perpendicular unit vectors. They are mutually perpendicular. So you can make this is the note like this. So let me write I cap, j cap. So from here I will proceed that h I cap, j cap, k cap are the unit vectors along x-axis. So here I have for two components I cap and j cap are the unit vectors along x-axis and y-axis So I can write this ax vector is equal to ax modulus I cap, or simply you can write ax I cap. I will not take this vector symbol, so it is the modulus. Then ay is equal to ay modulus into j cap. It's unit vector because j cap is along y-axis, along ay vector. J cap is along ay vector. So we can write ay j cap. Can you write this ay j cap? Clear? So now I can write this as a vector is equal to. Now I can write this a vector. A vector is equal to ax I cap plus ay j cap. This is the representation of the vector. Where x and ay is what? Where x and ay are the magnitudes. Of what? Magnitudes of ax vector and ay vector. They are along x-axis and y-axis respectively. Clear? That I have got this for. These are the two rectangular components. This is the rectangular component ax I cap and ay j cap. Now, what is this ax and ay? What is this magnitude? What is this magnitude x? Magnitude of point vector is x modulus of this one. So magnitudes of ax and ay, which is known as, already we have taken this as a magnitudes as a x and ay. Now we will get this x and ay in terms of theta. Clear? Now, from the figure here, in that triangle, right angle triangle, see ONP. What is cos theta? What is cos theta? NP, sorry, ON cos theta. ON by OP. Consider the magnitude only. So cos theta is equal to, what is ON? I will not consider ON vector, magnitude of ON. So that is the AX magnitude. What is OP? Magnitude of A. This implies AX is equal to magnitude of AX, means simply AX is equal to magnitude of A cos theta. This is X. This is X. Similarly, now we will go for what is sin theta. In that triangle, what is sin theta? In this triangle, what is sin theta? NP by OP. Sin theta. NP, this is the height by hypotenuse. NP by OP. So this NP is equal to OM. NP, what is this magnitude? This is same OM by OP. So sin theta is equal to, what is OM? Magnitude of AY, that is AY by A. Simply magnitude. If more is, you can put this more sign. It is not possible for always to put the more sign. So you can write this ay without vector. This is the magnitude. So ay is equal to a sin theta. This is ay. This is ay. So now we put here. So we got this ax and ay is this much. Ax and ay is this much. So now we can write this as okay. So now the magnitudes of ax form, how we will write this vector a? So now I can write vector a is equal to a cos theta ax I cap plus a sin theta j cap. This also, this is a component, this is the component, this is the magnitude part, this is the direction part, magnitude part, direction part, and this is the vector a, and this is the vector a. Okay, now how to find this magnitude of this a? What is this magnitude of a in terms of this ax and ay? From here, some other things are that squaring and adding these two. So now here what you will do? So squaring and adding the equation to the equations. So you have not put these equations. Okay. So also you can write this as now squaring and adding these two. Squaring and adding these two. What you will get? Square this. Ax square plus ay square. Ax square plus ay square is equal to a square cos square theta plus a square sin square theta. Isn't it? This square plus this square, LHS add, RHS added. Right? So now here we will get that ax square plus ay square is equal to a square sin square theta plus cos square theta. Take common a square. So a square, what is sin square theta plus cos square theta? 1. So ax square plus ay square. So a is equal to ax square plus ay square root over. This is what actually magnitude of a. The magnitude of a is equal to ax square plus ay square. Magnitude of a is equal to ax square plus ay square. So then what is this theta? How we calculate this theta in terms of ax and ay? Now you divide. We have sin theta by cos theta. What is sin theta? We have sin theta is what? Sin theta. So again you recall these equations like here. Ax is equal to a cos theta. Ay is equal to a sin theta. We got this thing. So if I make this as let me write this as ay by ax. What is that? Ay by ax. A get cancelled. Sin theta by cos theta. Because this is a sin theta, a cos theta. A get cancelled. So sin theta by cos theta is called tan theta. Tan theta is equal to ay by ax. So theta is equal to tan inverse ay by ax. Tan inverse ay by ax. This is the angle A max with x-axis. A max with the x-axis. This is the how I am playing with the rectangular components of a vector, and the two we are finding for two perpendicular components. Okay. Then the position vector in the plane. Now we will go for the position vector. See how I will go for the position vector. Already you know that position vector. And in coordinate system, already you know how to locate this position vector into two perpendicular components. Now, after knowing this one, now I will go for the position vector. Means I will note this position vector, then I taken as R. Position vector, we will take this as a R. Position vector in a plane. Means into two rectangular components. So let us consider a point in a coordinate system, two coordinate in a plane. The plane is the xy coordinate system, xy coordinate system. This is my origin. Let us consider the point P. What is the position vector of P? What is the position vector of P? What is the position vector of P? That is your OP. Join from the origin to that point, and what is its direction? Toward the point. Toward the point. This is the position vector R. And what is the coordinate of P? Go for your graph. Already know that. Go for your graph. If there is a point P, what is its components? Or what is the coordinates of P? Means you have to go x distance on x-axis, then y distance on y-axis, then you will reach at the point P. You are standing at O. To reach at the point P, how we can go? So I am standing here. This is a point. To reach this point, I will go this distance along x-axis, then I will go y distance along y-axis, then I will reach there. That is the coordinate. That is the position. Very easy thing. That is the position. So P can be written as x and y. Small x and small y. So these are the points. Means what? Means this distance, if you draw a perpendicular ON, this is your x. And if you draw a perpendicular to y, this is your y. ON. This magnitude is y, this magnitude is x. And let this position vector R, this is the position vector R. So, in the position vector in xy coordinate system, how we write this thing? So, if I write OP, if ON and ON, then according to this formula, what we discuss now, OP is equal to ON vector plus what? ON vector. So, these are parallel. ON vector plus NP vector. Plus NP vector. ON vector plus NP vector. I am finding the two rectangular components of position vector. Rectangular components of the position vector means along ON, along x-axis, along y-axis. So OP is equal to my R vector. That I can write this. ON vector. ON is the x vector plus NP. NP is nothing but ON. NP, that is equal to ON vector. NP is equal to ON vector. So NP I can write this as a y vector. So as you know, along x-axis your I cap, along y-axis unit vector is j cap. So I can write this as R is equal to x I cap y j cap. This is my position vector in a what? XY coordinate system. In XY plane. XY plane. So what is the magnitude of this R? Magnitude of this R, position vector. That is your x square, ax square plus y square root over. This is the magnitude. So I can write this as R like this. So this is the vector, this is the magnitude. If similarly if I will ask yz plane, position vector in yz plane. Suppose this is y-axis, this is z-axis in yz plane. So this is y, this is z. So I can write this as R is equal to in yz plane. Y-axis, what is the unit vector? J cap plus z-axis z k cap. Z k cap. What is the magnitude of this R? That is equal to R is equal to y square plus z square. Similarly, suppose zx plane. If the position vector in the, I am writing for two components, that's why I am taking each two pairs. Z and x. Z axis and x axis, they are also mutually perpendicular. Xy perpendicular, yz perpendicular, zx perpendicular. So these are the perpendicular components. So zx plane. So I will write this R is equal to zx. Means x I cap plus z k cap. Vector addition is commutative. You can write z k cap or x. And remember one thing. This is a vector. This is a scalar. This is a vector. Unit vector. It has direction, but it has no direction. It is magnitude. It has magnitude. So like that. So R is equal to x square plus z square. So this is the what? The magnitudes of this vector. Okay. Then, if this is the case, now what is this R? What is this R? Means what is this x vector? What is this x? On in terms of r. What I would write? If this makes an angle theta with x axis, then what is this x? X vector. R cos theta. Ax. A cos theta. R cos theta. I cap. What is y? R sin theta. J cap. See that. What is along y vector? If this is x vector, this is y vector. R sin theta j cap. That already you calculate. Okay. Now we'll go for the displacement vector in terms of components. Now we'll go for the displacement vector in terms of components. Let me erase this one. So already we discussed about displacement vector. Particle moves from one point to another point. How to calculate displacement vector? Let me again add. But I am discussing about in a plane, so I will take only 2 coordinates. In space, 3 coordinates. I am in this plane, so it needs 2 components. I am here. If origin is B, I am the origin, this is the object. I need 3 components, space. If this is the plane and I am also in this plane, so I need 2 components. So that is in a plane means 2 components, space means 3 components, means 3 coordinates. So how to look at the displacement vector? Now let us draw this displacement vector case like this. So this is your x-axis, then this is the y-axis. X-axis, y-axis. Let us consider the particle at point P having coordinates x1, y1. And this is the origin, and this is the particle is the plane P. What is the position vector? Let this is the position vector, that is your r1. At time t1, the particle is at the point P. Now the particle reach at the point Q. Now the particle reach at the point Q at a time t2. What is this coordinates? Q has coordinates x2, y2. x2 and y2. Means to reach at Q, I have to go x2 distance and y2 distance. Let the position vector of Q is this one. This is the position vector of Q, r2. It is towards the point along the direction. Then what is the displacement vector? From this point to this. This is the displacement vector PQ. PQ is the displacement vector. Clear? PQ is the displacement vector, and I have to find out PQ. I have to find PQ in terms of rectangular components. We are playing with rectangular components. Okay. Now, how to find this PQ? Now already you know that the position vector r1 is equal to x1. What is the component? x1 along x-axis plus y1 along z-axis. So jk. It is written in terms of what? Unit vectors of the position vector. Already you know that. Then what is r2? x2 I cap, y2 z cap. These are the position vectors at time t1 and t2, right? r1, this was at time t1, at time t2. Then what is the displacement vector? Displacement vector, already you know that. Displacement vector in time interval t1 minus t2. In the time interval t2 minus t1. In this interval, what is the displacement vector? In the time interval t2 minus t1 is which one? P2Q, from initial to final, and the direction is from initial to final. That is the displacement vector. How much it is covered from the starting to final. So the direction should be, because this is a vector, so direction is must. So PQ. So what is this PQ? What is this PQ? Use the triangle. Already you know that PQ is equal to how much? R2 minus R1. Triangular vector addition. It is, this direction is fixed. So what is this direction? R1 plus this. How we are getting this one? R1 plus PQ is equal to, they are in the same order. So this should be R2. So PQ is equal to R2 minus R1. Remember this thing, remember. Okay? If you are not getting, then go to the last, in which video we have discussed. Everything I told that, and remember what I am telling also, that is important. So PQ is equal to R2 minus R1. Do the subtraction part. R2 minus R1. Okay. So now I can write this as PQ. Let me give this a symbol delta R. Displacement vector. PQ is equal to delta. Some change, that is delta. So R2 is x2 I cap plus y2 j cap. This is the vector minus x1 I cap plus y1 j cap. So this is equal to x2 minus x1. Take this I cap common, right? Plus y2 minus y1. These are scalars. J cap common. This is equal to delta. So this is O. Delta R. So this is the position vector. Delta R equal to this one. If I ask you what is this magnitude of this displacement vector, delta R is equal to what is the component of I cap? X2 minus x1 its whole square, ax square plus ay square, y2 minus y1 whole square its root over. This is delta R. This is my delta R. Clear? Then next we will go for, like that I will go for the rectangular components in 3 directions, in the 3 coordinates, means resolution of a vector into 3 rectangular components similar way. Now we will go for the resolution of a vector in 3 rectangular components like 2 rectangular components. Means in 3 rectangular components means we have to consider the x-axis, y-axis and also the z-axis, and this is the origin. Let a vector OP is a vector A. I will not draw the figure. The figure is very much complicated like that, so it is not possible to draw here also. Okay, so I will go according to two rectangular components in 3 dimensions. Means you have to imagine for space also. So it is very difficult to locate the space point because we are not experts in drawing the 3-dimensional figures. We are not expert to draw the 3-dimensional figure. You have to imagine there is a component z-axis like this, isn't it? 3 components x, y, z. This is the z. Means the vector is not here, p is not here. The case is like this. X, let me show like this. X, okay, x, y, z. X, y, z. And the vector is like this. Vector is like this. So its component along x-axis. Its component along x-axis. Like this is the component along x, m. Along y-axis. N, ay. Along z-axis. So again here difficulty. Along z-axis means at that time. So N, you can take Q also. This is your AZ. Right? AZ is like this. And remember another thing is that. Suppose this A makes an angle alpha. Let me use another pen like this. Let this A makes an angle alpha. A makes an angle beta with y-axis, and A makes an angle gamma to the z-axis. A makes an angle alpha with x-axis, beta with y-axis, and gamma with z-axis. Why I have taken like this? In 2 dimensions, if I take A makes an angle theta with x-axis, then how much angle it with the y-axis? 90 minus theta. 90 minus theta. But here you cannot say like this. So this is the vector, yes? X-axis, y-axis, z-axis. So this is the vector. It makes an angle alpha with x-axis, beta with y-axis, and gamma with z-axis. I don't know because this is not the 180 or 90 like that. The sum is like this. So it makes the angles like this. Now I will show this one. How we will show this? So as the same procedure, as we are getting that, so I can write this A vector is equal to Ax vector. These are the components. Ay vectors plus Az vectors. Because this A vector is the sum of Ax, Ay and Az. If they are the components. Where this Ax, Ay and Az are the three rectangular components along what? X-axis, Y-axis and Z-axis respectively. Along X-axis, Y-axis, Z-axis respectively. Okay. So what is this Ax? Magnitude I cap. What is this Ay? Magnitude J cap. What is this Az? Magnitude K cap. I cap, J cap, K cap are the three orthogonal unit vectors along x-axis, y-axis, z-axis. Remember this thing. Repeat this thing. Okay. Bar. You have to repeat that. I cap, J cap, K cap are the unit vectors along x-axis, y-axis, z-axis respectively. Like that. So magnitude into unit vector. So accordingly I will write this as according to this X I cap, Ay J cap, Az K cap. This is the vector. This is the in terms of component part. What is the magnitude of this one? What is the magnitude of this one? This is equal to, what is the magnitude? For 2x square, Ay square, Az square, root over. This is the magnitude. For 2x square plus x square. In 3 dimensions you can show that. You can also derive this thing. But I am not going for, because already you have gone for 2 dimensions. Accordingly you draw the 3 dimensions. Means you will consider a cubical ball. Like that. You will get a cubical shape. Right? Then this is the magnitude part. Next. Then here also we will go for the direction cosines of the vector. At what angles? What is this alpha, beta, gamma? That is called direction cosines. Direction cosines of a vector. Here, this part is clear. Now we go for the direction cosines. Here, what is alpha, beta, gamma? Like that sin theta, cos theta you are getting in 2 dimensions. But here you will get alpha, beta like that. So next is the direction cosines. Direction. These are called direction cosines of a vector. In 3 rectangular component form, what are the direction cosines of the vectors? Right. So the direction cosines of a vector are the cosine of the angles. What is direction cosines? It is the direction cosine. It is the cosines of the angle. It is the cosines of the angles. Cosines of the angles of a vector. Of a vector. Cosines of the angles of a vector along. It is the cosines of the angle of a vector. It is the cosines of the angles of the vector along x-axis, y-axis and z-axis. Means I will write this in cosines. Okay. So the direction cosines of a vector are the cosines of the angles which the given vector makes with the x-axis, y-axis and z-axis respectively. Right. So here we have considered alpha, beta, gamma are the angles with x-axis, y-axis and z-axis. You can write also this alpha, beta, gamma are the angles made by vector A with x-axis, y-axis and z-axis respectively. Isn't it? Respectively. Okay, you understand this thing. What I am telling you, can accordingly I am writing very fast. Okay. So now along z-axis respectively, then what I can write here? What is cos alpha? cos theta. Go for 2 dimension. What is cos theta? What is cos theta? In 2 dimension case, again only vector A, this angle is theta along x axis, y axis. What is ax? So what is this ax? Means in this right angle triangle. We are considering this right angle triangle. Here also this right angle triangle. Cos alpha. What is cos alpha? OM by OP. Means cos alpha is equal to AX by A. Similarly, cos beta, AY by A. Cos gamma, AZ by A. This is difficult because this is in the 3 dimension. So accordingly I will put that as cos gamma as AX by A. So this cos alpha, cos beta, cos gamma, they are called as, this is called as generally L, this is called as M, this is called as M. LMN are called direction cosines, or cos alpha, cos beta, cos gamma. In short form, they are called as LMN. Okay. So where this means to get this one, these are the called direction cosines, cos alpha, cos beta, cos gamma. And now we'll get a very important result here. What the result? So as you know, as a square or a is equal to ax square, ay square, az square, isn't it? Square root of this one. If you take the square root out, then you have to make this side square, this is square, a square. So this means a square is equal to ax square. What is ax square? A cos alpha square means a square cos square alpha. Ax square, a square cos square alpha. See here, ax is equal to a cos alpha, ax square equal to a square cos square alpha. Plus ay square, a square cos square beta. Az square, a square cos square gamma. Take this a square common. So a square is equal to a square of cos square alpha plus cos square beta plus cos square gamma. Isn't it? So a square cancels. So what the final result? What the final result? That is most important. What the final result? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is the direction cosines result. Right? Squares of direction cosines, squares of the direction cosines are of a vector is equal to always 1. Is equal to always 1. Okay? Or you can write this cos square alpha means L. L square plus n square plus n square is equal to 1. This is the resolution of a vector in 3 rectangular components, and what are their direction cosines. Similarly, now you tell me how to write the position vector. How to write the position vector and displacement vector. How to write the position vector and displacement vector in 3 rectangular component form. Position vector and displacement vector means now I will go for the position vector in space, not in plane. What do you know in space? Plane. So this space means we have to consider 3 coordinates which are mutually perpendicular. As you know, x, y, and z and x, y, z are mutually perpendicular. So this is the position vector of a point, suppose P. So this is the position vector R. So how to write this R? R is equal to x plus y plus z because it is in space. Or I can write this R is equal to, what I can write? This R is equal to x in terms of unit vectors. X I cap, y j cap, z k cap. What is the magnitude of this R? X square, y square, z square, root over. This is the position vectors. Yes. Right? In our what? The position vector in our space. Similarly, displacement vector. displacement vector in space. How to write this displacement vector? So now you tell me, in this case, x, y, z are there. There are 2 points of P. What are the coordinates? Maybe x1, y1 and z1. To locate a point in space, we need 3 coordinates. Are you know this thing? P the point having coordinates 2, -3, 1. To locate this point, x-axis 2 direction, y-axis -3, z-axis 1, like that. So x1, y1, z1. Now the particle goes to the point Q. So its position vector let R2. Here position vector is R1. So its coordinate x2, y2, z2. x2, y2, z2. Let me write this z2. Right? And what is the displacement vector? From P to Q. That is the displacement vector. So PQ, that is delta R in 3 dimensions. So delta R position vector is equal to what? OQ vector minus OP vector. So delta R is equal to R2 vector minus R1 vector. So delta R is equal to x2 minus x1 I cap. Go for 2 dimension plus this delta plus R2 minus R1 y2 minus y1 j cap plus z2 minus z1 k cap. This is the displacement vector. What is this magnitude? Delta x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Root over. Isn't it? This is the root over. Root over of this one. Right. This is the root over of this one. Okay. Root over. So these are the position vector in a space and displacement vector in a space. So all total, you know the resolution of vectors. But always remember, when you go for the resolution, and this is resolution is very important. We have gone for 2 dimension, 2 rectangular component, 3 rectangular component. And remember this last topic thing that when you are considering this vector A along x-axis and y-axis, if this makes an angle theta, so we are writing A is equal to A cos theta, AX cos theta I cap plus A cos theta I cap plus A sin theta j cap. So what is the sin theta actually? This is nothing but vector A is equal to actually A cos theta I cap plus, we are taking this triangle, but A sin theta I can write this as A cos 90 minus theta j cap. Cos 90 minus theta is sin theta. Means A makes an angle theta with x-axis, so its component along axis A cos theta I cap. Now this A makes an angle how much with y-axis? 90 minus theta. So that is cos. So it is always cos. A cos theta, A cos 90 minus theta. If it makes an angle alpha, so I will write A cos alpha. If it makes an angle beta, so I will write here A cos beta j. So this is the case. Means if a vector is given, if it makes an angle with any axis, then its component along that axis means the vector, magnitude of that vector, cosine of the angle. Clear? So this is the vector P. If it makes an angle alpha with this axis, I don't know x or y axis, and another axis is there, this is perpendicular, these two are perpendicular, then what is P along this axis? P cos alpha. And if it is perpendicular, so this axis means how much? This will be, suppose this is 90 minus, this must be 90 minus alpha. So what is the component here? In this direction, P sin alpha. P sin alpha or P cos 90 minus alpha. This is the way to find the components of a vector. Friends, I try to go give you as much as knowledge about this resolution of vector, and remember this thing, this resolution of vector is very important for your due course of time. Always you will get this one. So now you start do or play with this resolution of vectors, how to make this resolution, how to get the rectangular components. And this is required in your whole life, then so long as you are in science. So long as you are in science, this resolution, this components form are very, very important. Thank you so much.